All right, so how's everything going? I don't know if that's readable with the windows open or not. Is that legible?
Yes.
A little bit.
A little bit?
Hard to read, but good.
Okay. If you need the windows closed, give a shout. Otherwise, we're just gonna run with that. All right, so PA1 is graded and commented and such like that. So good job on PA1. First of all, nobody munged up their tar files, which is amazing. It's the first time it's ever happened. So good job with making tar files and not destroying your code in the process. And by and large, most of the scripts ran, which is good. Few of them that had syntax errors, so they wouldn't run at all. But by and large, most of them ran, and most of them nailed the gameplay pretty perfectly. Deductions were mainly for this issue of, allowing unlimited tries to specify how many sticks you want to start with, or who wants to go first, or only allowing 2 tries when you're asking how many sticks to take. Little details around that, right? So a few points for that. Variations from the program spec. So I allowed a little bit of wiggle room, but if you just decided the computer was going to go first, for example, or things like that, deductions for that. Commenting, I saw a lot of good commenting. Okay, so I think people are on top of that already. Remember, the goal of commenting is the following. One, you always want a comment block on the top to say who you are, what is this, when did I write it, okay, and whatever else you feel you need to include about it. You want to comment major sections of your code. So here's the section where the computer decides how many sticks to take, right? Have a nice comment there, have some empty space around that so that jumps out at you and is easy to identify. But also, code itself, right? Each line of code, you can have a number sign at the end and put a comment on that line. So when you say, sticks equals num%4, if sticks equals 0, then sticks equals 1, it's probably worth having a comment somewhere in there saying what the heck you're doing, right? Why are you setting sticks equal to num%4? Well, because we want to leave a multiple of 4 sticks. And so if we take sticks% 4, that'll leave a multiple of 4, right? That's worthy of a comment probably somewhere in there. And then this if statement that says if sticks equal, if num%4 is 0, sticks equals 1, right? We're not allowed to take 0 sticks, but we can't make the pile 0 mod 4, so we're taking the smallest number possible, right? So don't be afraid to put comments on the individual lines of code. Again, if you say I equals I plus 1, don't write a comment saying add 1 to I. That doesn't really help you when you're looking at this, but why are you adding 1 to I, right? Keep track of the number of turns. That's a good comment. So so go ahead and do that. Other than that, I think it was a great job on PA1. I think you're in good shape for PA2 as far as understanding what you're supposed to be doing in the program. Remember, PA2 totally changes the rules for invalid entries. Okay, so invalid entries can be totally crazy. And the initial questions, if they don't respond appropriately, the game's over. When you say how many sticks do you want to take, that they can do as many times as necessary until they put in a valid answer. Test your edge cases. So I found a number of cases where code was accepting 0 as a valid number of sticks, right? And it was picking up things bigger than 3. It was picking up things like ha, but for some reason 0 was sneaking through. And remember these guidelines when you say something like x equals $paren 2 times x plus 1 paren, no spaces. You can get away with it sometimes. You can put spaces around the plus sign and it may work or it may not, right? This will work. If you have no spaces in there, guaranteed to work. Okay, assuming everything else is correct. But if you decide to, put a space after the parentheses, you're on your own. Okay, you really, really, really want to test the heck out of it. If space, bracket, bracket, space, condition, space, bracket, bracket, right? Lots of spaces. Again, sometimes you can get away leaving those out, but buyer beware, and so on. But we're doing C for PA2, so we're away from shells for a little bit. So any questions on PA1? All right. Let's continue with Git. So does anybody want to guinea pig themselves here? All right. You have a GitLab account?
Oh, I don't.
You don't? Well, you can set it up if you want.
Yeah, I do.
Okay.
That's what I was hoping.
Okay. You got a laptop here?
Yes.
Okay. Actually, we can do it on this one. All right. Do you want me to stop the recording, or don't you care?
I don't care.
Okay, come on up. All right, we've never met before, right? No. All right, so GitLab.com, right, and go through the regular process you go through whenever you sign up for something.
I can't spell, so.
That's okay. Cool. I'm guessing it'll send you an email.
Oh, great. So everybody gets to look at my email?
Well, no, you can do it on yours if you want. Does that have an HDMI port, by the way? No, it's got VGA, and I don't think I have the right cable. Okay, well, we can just run on this.
Sorry, I'm not prepared.
That's okay. So this is the usual, right? It sends you an email to make sure you're not, like, spoofing your friend. And what I want to show you is basically how you set up this authentication between your machine and GitLab. Which we probably are going to do on your laptop, because we don't want to authenticate my machine for your account.
Yes.
Or we can do it on the Linux server. That would be fun.
So, should I log in from here?
So did you do your email? Okay. So let's see if we can just come back here. So go ahead and sign in here. Let's see if it. Cool. All right. So next thing, you're A. Hopkins. Just go ahead and log into the Linux server. I'm going to set up a GitLab between Linux and
Oop, if I put in the right.
GitLab.
Did I know?
Control U.
Control U.
Yeah. And then try it again.
Ah, there we go.
All right. So you've got a GitLab account. So what's the easiest way to do this? So let's come over here. Have you ever set up Git on Linux? Okay. So let's just make a new directory called test project. And let's just make some files. All right, so you got all right, so you got two files, a.c and main.c. So to initialize get, do you remember the command? Get init. All right, one-time thing. So then you add these files and then you commit them. Oh, okay. So getting ahead of ourselves. So you've got to do this other setup. All right, so you need to do 3 commands. This git.config -- global user.name and then your username. And then what was your username on GitLab? A.Hopkins. 2013. All right. And then user.email. And then what's your email?
Same thing at gmail.com.
That's convenient. And you okay with VI? Okay. So -- global core.editor. And then VI. All right, so now if you say git commit, it'll open up a VI window and let you type a message. So this is initial commit of sample code. All right, so you have a Git repository on the Linux server under this test project directory, right? So your next goal is to link it to GitLab. And normally you could do it like this. So git remote add origin git at gitlab.com. That stuff is all boilerplate. colon a.hopkins 2013 slash, let's just call it test project. So what this would normally do is it will go ahead and it will clone the repository from the Linux server to a repo at gitlab.com. And then you've got a repo in the cloud. But if we try to do this, when you try to actually push it over, it's going to complain that you don't have access rights. So rather than having you put in a username and a password every time that you move things back and forth, you set up what's called basically a secure handshake. Okay, 215. A couple of weeks we're going to talk about public key crypto systems. Secure handshake is a way that basically you put something on the server, and when it sends that something to you, you're the only person who can reply with the expected response, right? And it authenticates that you are who you say you are. But this is a one-time setup. So I poked around last night trying to find this. So I think it's under your window over here, go down under settings. Internet. Spinning circle of doom. And come down here to where it says SSH keys. Okay, and there's basically instructions here. So it says to add an SSH key, you need to generate one or use an existing key. So click through on generate one. And for different operating systems, it'll tell you how to generate a key. So for Windows, Linux, OS X, right, SSH-keygen. So SSH-keygen space -o-t, so that's the type is RSA, C a.hopkins 2013 at gmail.com, and then a block size of 4096. And we don't really have to worry what any of this stuff means, okay? You just have to make sure you type it exactly like this. And then take the default here, so it's generating a pair of keys, right? One that's in the public domain, one that's private. Take the default, it'll store it in the expected place. Passphrase you can leave blank, it's an extra thing, but then you have to type it in every time. And then this you can put at the bottom of your emails and people will think you're really cool. All right, so blow through all of that and come into your home directory, and now you've got a subdirectory called should be a .ssh. Oh, colors. Okay, so go into .ssh. And there's a pair of files in there, IDRSA, which is your private key, and IDRSA pub, which is your public key, right? And the basic idea is you can give people the public key, right? And the public key can go together with your private key to authenticate you, but there's no way to figure out what the private key is from the public key. So you can use one of these for encrypting and the other one for decrypting. Anybody can encrypt stuff and send it to you, but only you can decrypt it. So take a look at idrsa.pub, and that's your public key. So copy that. And then come over here to SSH keys and paste it in here. And that's not a good paste because it's got spaced carriage returns in it. Oh boy. Alright, well, let's see if it works. So I'm going to put a title down here, and I'm going to just say Linux server. I've got a feeling I may have messed this up.
I think I messed mine up too.
Yeah? Okay. The whole trick is you want to paste it without like artificial carriage returns popping in. So don't use like Notepad or something. All right. So now you've got a key set up over there. And let's come back here under test project. And let's just do that push again and see if we can get lucky. No. Well, bummer. All right, close your eyes. Now you don't have to close your eyes. Take one shot at this. Because I might have broken something a few weeks ago. All right, so the first time that you try to do this, or the first time you use PuTTY to connect to a server, you get this potentially scary message saying authenticity can't be established, right? This is just one of those things with security. So you have a friend who's moved away to the other side of the country, and you're talking on the phone, and it's like, you know, we should set up a secret password so we actually know we're talking to each other. So I'm going to say such and such, and you're going to respond with this thing, and that'll be how we know that, you know, you're you and I'm me, right? Make sense? The problem is, how do you know that that's who you're talking to right now? What if somebody's already come in and intercepted your phone call and is pretending to be your good friend? Okay, that's what this is saying, right? At this point, there's no way to know that we're actually talking to GitLab, and GitLab has no way to know that it's actually talking to you. So the first time you do this, you got to kind of have trust there, right? Once you say yes, then it's going to use this public-private key to make sure that you can handshake securely. All right, so you're authenticated, but your project's not there. And that's annoying. Let's see if you got any projects. No. All right, my half hour is up. All right, I will spin this out at home and figure out, or keep messing with it if you figure it out. But I also don't know what the deal is with these. All right, thank you anyway. Well, that's most of the steps. But I got to figure out this business of this client alive. So see, it's easy. I will play around with this, possibly not until tomorrow, but I'll make a new GitLab account and figure out all of these details, and I'll make a video of it and post that. How's that sound? All right, so let's go on. So let's talk about labs. So I've posted your first lab assignment, and I've made it due a week from today. Normally these will be due on Fridays, but I'll give you until Monday for this one to give you a chance to write it up. But you'll want to do the lab work this week. So you're working with these things. So this looks like a giant USB drive. It's actually a Raspberry Pi inside. So it's a full little Linux box in a nice form factor. And you take it and you basically plug it into a USB port, and you wait a minute and it boots up Linux. And you can connect to it through PuTTY if you're on Windows. You can connect to it through Minicom if you're on Linux, and you can use Minicom on app, but app is always a pain with this. But there's some information in the lab for how people have reportedly been able to do this using a Mac. So here's your lab. So this is basically just kind of plugging the device in, messing around with it, getting logged in, seeing what's going on. So first things first, we have, I believe, 17 of these devices now. A few of them walked last year, and I made a few new ones. So we've got 17 of these. They're sitting in the collaboratorium in a cabinet towards the back right corner. Okay, and they're in a cabinet labeled 222, 3, and 4. And there's a sign-up sheet on the door for the lab groups. So it's probably going to be 3 to 4 people per group. Okay, don't do more than 4. Don't do fewer than 3. I'd rather you do fewer than 3 than more than 4. But 4 people per group would be 68, and we only have 65 people signed up, so that should work. A few groups with 3. The units are essentially identical, except they come in different color combinations, so you can pick based on that. And your proto board is this big, right? So they're not like giant labs. And mostly you're going to have an LED or a button, or maybe an LED and a button. So they're not intense labs like 250, 270, right, where you're building. Right, it's really just a way to access this thing, because on the sides of these, well, it's pretty hard to see, but there's a grid of holes here. Okay, these are places you can connect things to. And there's a little label 1 and 2 over here that you can see if you actually look at the physical device. So there's 40 holes on the side here, okay? And you can access different I/O functions from software that will basically either send voltages out these holes or read input from those. Okay, so for example, we can hook an LED between pins 13 and 1, I believe, and using various bash commands, we can make that LED light up or turn off. Okay, or you can hook a switch up between one of these holes and ground, and then using various bash commands, we can say, is that input ground or is it high? And so it lets us write shell scripts or C code that will interact with basically LEDs and switches, right, through this Raspberry Pi. That's a Pi Zero inside. They cost $5 if you buy one. They're well worth like throwing in your toy box, and it's a full-blown Linux system, right? All right. So what are you doing for Lab 1? So find the boxes, figure out who you want to work with, put your name on there, and this will be your lab kit to use throughout the quarter. Please don't take the boxes out of the collaboratorium area, though, because inevitably people do this, and then I get a panicked lab partner coming to me saying, I'm trying to do my lab and my box isn't here, what should I do, right? So that's the first thing, leave them in the lab area. Second thing, don't take them apart. Now some of them, the covers come off pretty easily, and if that's the case, let me know and I'll throw some tape on it. But don't take them apart. I don't care if you know what's inside, but if you take them apart and you put them back together and you don't put them back together the right way, they break. Okay? They've survived a couple of quarters worth of use, but they're still fairly delicate. Right? There's wires inside. If you just sort of pull the cover off and then like slap it back on, there's a good chance you're going to pinch some wires and break a connection. If the cover comes off, come and find me and I'll put it back on for you and I'll throw a zip tie around it or something. But other than that, they're fairly indestructible. Other thing, don't make changes to the configuration, like changing the password to the main login, unless you clearly communicate with your lab partners. Okay? Because I get people who come in and they say, my Pi is doing something really weird, and the person's like put a new operating system on it and didn't tell anybody. Stuff like that. So just common sense things. All right, so how do you use this? So plug it in, you'll see a little red light start to flash inside, and after a few seconds it'll start booting up. So on Linux, sudo minicom-d, and it's usually /dev/tty USB 0 if you just plug this in. If you have multiple devices, it might be USB 1 and so on. And then Control-A, Z, P, E, Enter, etc., etc. Various instructions here. On Windows, you can use PuTTY, right? So select a connection type of serial instead of SSH, and you have to go into either your device manager or use the command mode to see what COM it decided to hook this up to, the usual Windows thing, like when you try to use an Arduino. Figure out what the COM port is, set your speed to 11.5.200, open the connection, bang on the Enter key until it starts showing you stuff, and it should show you boot up messages. And I think I can do this. Just have to kill my mouse. So I have an alias set up here for sudo minicom. So I'm just going to plug this in. And I've already set up the baud rate once, so now this is coming from the box, right? This is the Linux boot screen. And it takes a little while to boot, but you should get a bunch of messages. And then eventually it should give you a login prompt, right? And now I'm connected to this box. So the default username is Pi, the password is Raspberry. Throw my mouse over here. Username Pi, password Raspberry. And that's it. I'm logged in now. So I've got stuff on mine. Yours should be mostly a blank slate. All right, with me so far? All right, if you want to make your own login, you can do that, okay? Use the command add user, and you can create your own login, give it your own password. If you want to change the password on the account, just make sure everybody in the group knows what the password is. And if you forget the password, I can reset the machine to its initial state, but much better if you don't forget the password. All right, so what are you doing for this lab? You're just doing a couple of commands and looking at some stuff. So log in, run the df command, okay? df is a Unix command that shows you the different file systems, okay? Windows would call them partitions, but the different file systems where you can store information. And some of these machines have 8 gig of storage, some have 16, some might have 32. So run the df command, see how much space is in use, how much is available. Okay, and pay attention to units because it just gives you a number, but is it gigabytes, is it megabytes, is it kilobytes? So how much space is available. If you only have like 2 gigabyte of space available, step 2 says go ahead and run this command raspi-config, and you need to put sudo in front of it. So Unix right, so raspi-config is just a command. But it'll tell me that's got to be run as root. Okay, so root is the privileged user on Unix, and you can't usually log in as root. Root is also called the super user, so you can use this command super user do, and then you can put in a command, and it'll ask you for your password if you haven't done it for a while, and you get this weird looking window, but you know it's an ASCII art window. You move around with your arrow keys and so on. So run raspi-config. If you only have 2 gig of space available, run raspi-config, find the option that says expand file system, say yes, expand the file system, reboot, rerun the df command, see what changed. And then go back into raspi-config, look at 3 other options, do a little research, okay? This is a chance to explore this device. You want to get to know this. And it's a chance to explore a Linux system. If you haven't run Linux on your own machine before, this is your Linux system, okay? So you can get to know it. You can do things as root, which you can't do on the server that we use for the class, but this is your machine, right, for the next 8 or 9 weeks. So play around with it. See how much memory is available on the system. So a command for doing that is top. Top will show you the top CPU using processes, and it updates every few seconds. So play with that, look around at what it's doing, hit Q to exit the top command. See how many tasks are currently running on the system. Okay, even though you're the only person logged in, there's a lot going on. Then go into the directory /boot/x first, see what's in there. Go into the packages directory, see what's in there. Use the cowsay command to generate a message and copy and paste that into your lab report. And finally shut down the system with the command sudo shutdown -halt now. And that's your whole lab 1. Okay, so there's no actual circuitry to build, but it's actually connecting to this device and playing around with it. So write up a report, save it as a PDF, submit it to Canvas by Monday. I think it's an 8 a.m. due date again. And strongly recommend shutting this down before you're done with it. Don't just yank it out. Yeah?
Is this one report per group or per person?
One report per... Let's do it per group. What the heck? Okay, so one report per lab group. So make sure that you're happy with whoever's turning in the report. All right, so when you're done, shut down, sudo shutdown -h now. Wait about 7 seconds, and it should say power down. And then you're free to take it out. And then you're done. Does that make sense? So have fun with these, okay? Linux server is kind of locked down. You can do things in your account, and that's it, right? This thing, you can, change the boot up sequence, you can install software, you can do whatever you like within reason, right? If it gets totally hosed, bring it to me and I'll just reflash it to its initial configuration. There's no Wi-Fi on here. That's deliberate, right? So there's no Google, there's no downloading, but get to know copy and paste, right? If you write code or have code on another machine, right, you can copy it and then go into a window here and go into VI or something and paste it. And that's not a bad way to do file transfers, okay? But it kind of forces you to get really good with VI, okay? And do your development on here, make yourself some tools, things like that. But you got a lot of freedom there. All right, so questions about any of that? All right, so we talked about scanf last week. Right, and it's like scanf, but your first argument is a string, character array. Your second argument is a format string that looks a lot like a printf string, and then your third argument is the variable. And this is really all you're going to need for your ODP. Okay. Now, if you want to read from the user while your program's running, we talked about fgets, which takes a character array, a length, and standard in, which is a predefined variable. But for your ODP, you don't want to read a program input. You want to process a command line argument. Okay, so let me show you what your ODP should do. All right, so S1 is my ODP. Program name, space, floating point number, enter. It prints out the square root in that format, and that's it. Okay. So no prompts, no welcome to my square root program. We're going to print the square root of your number, right? Only output is the square root, and I think it says to use %lf for the output. It says in the assignment, followed by a new line, and that's it. And it's got to work off the command line argument. Okay, so write a C program, takes a command line argument, prints the square root. Yeah.
So we're allowed to use the root function for this?
Yes, absolutely. Yeah. So when you link it, right? So include math. And when you compile it, do a -lm switch at the end that says include the math library. And your function is just square root. Takes a double, returns a double. Is that clear? All right. So that's ODP 408. We skipped a few numbers. That's all right. So that's closes at 8 o'clock tomorrow morning. All right, I'll let you out 55 seconds early. So I'll see you next time.